Okay, for this one I have a new word for you. It's called one-to-one. First of all, if we know something is a function, that means every x has its own y. That was something we learned quite a while back. Okay? In a function, every x has its own y. If it is one-to-one, then every y also has its own x, which means every x and y are paired singularly. Every x has its own y, and every y has its own x. In other words, if I have a function and it has an inverse that is a function, then we call it one-to-one, and this is the shorthand for one-to-one. It's like a score, right? We're keeping score. Every x has its own y, every y has its own x. So, remember our vertical line test to tell if something was a function? Well, then it passes the vertical line test, but there's also another test. The vertical line test just tells you that the original is a function. But if I do something that is the horizontal line test, that one tells me if the inverse is a function. Okay, so both tests have to happen. It passes the vertical line test to see that it's a function, and it passes the horizontal line test to see if its inverse is a function. So all we're going to do, and you should just draw yourself a picture of one that is and one that isn't, or just all three. I've got 3 of them here, okay? I just want to know if each one is one-to-one. So keep in mind that it's going to pass the vertical and the horizontal. And let me talk to you just briefly about that whole, x and y having the same. Okay, so this is an exponential function. You see? Does it pass the vertical line test? Yes. Does it pass the horizontal? Yes. So this one is one-to-one. Now, if I go in here, what I can see is this x has only one y value, but I also see that this y has only one x value. So every x has its own y, and every y went the wrong way, has its own x. What in the world? Okay, so let's try this one. Does it pass the vertical? This is your cube root. Do you recognize it? It looks kind of rough right now, doesn't it? These are drawn on PowerPoint. So, does it pass the vertical line test? Yeah, it does. Does it pass the horizontal? Yeah, these are asymptotes, so it's approaching ever so slowly, but it gets there. So that one is. Look at this guy. Is that one? Oh, it's absolute value, our old friend. Is it one-to-one? No, look. Vertical line test is good. Horizontal line test? No. Okay. So make sure that you understand the difference between them. It needs to pass both tests when you are doing this graphically. Okay. Now, algebraically, it needs to pass an entirely different test. Marker. It's okay, we're just going to ignore all those little points. Algebraically, what's going to happen is the composition of f and f inverse is going to equal x when I simplify. But also, at the same time, the composition of f inverse and f is going to equal x. So we are going to show something is one-to-one, and when I say show algebraically, it means that you're doing a little mini proof. These are called algebraic proofs. It's not a 2-line, 2-column thing. It's a showing step by step that this works. Alright, so here's f of x. Ain't he cute? You know what we need? The inverse. So I'm going to go find his inverse. Remember what we do? Switch x and y, solve for y. Whew. Oh, that was rough. That was rough. Sorry, that's why. There's the inverse. X plus 4. Okay? So now we're going to do the composition of f and f inverse. Remember what this means? The inverse into the f function. So x plus 4 goes in here. So I'm going to replace this with x plus 4 minus x. X plus 4 minus 4 is x. Woohoo! It's x. That's what we wanted to happen. See the other one? The other composition is f inverse and f. So the f function goes into the inverse. So I'm going to put x minus 4 in here. So I have x minus 4 plus 4. And what does that simplify to be? Yeah, x. This is a proof that f of x is 1 to 1, because both of them simplified down to just be x. Y equals x. Okay? So, in math, when we're doing proofs, and this is for those of you who get to go on in math and you might have to see some other goodness, what we would say is, you could say QED, which is a Latin term, that just means that it has been proven. Okay? Or you could say, therefore f is 1 to 1. 3 dots means therefore. It's in a little triangle. Okay? So you could say QED to show that it has been proven. That's all that means. Or you could say, therefore, f is 1 to 1. Neato, right? So you could say it either way. Alright. I want to do that one more time. There's my fancy function. We're going to find its inverse, and then we're going to check if it is 1 to 1. So this is f. For f inverse, we got to switch x and y and solve for y. What I'd like you to do is to hit pause and try that on your own first. Okay? It's just the safety of your notes. It doesn't matter. Just go ahead and switch x and y and solve for y. I'll wait. Here we go. Actually, I want to have a little space down here for my writing later. I'm going to move up here. So I'm going to make this. We're going to multiply both sides by 3 plus y. That makes that cancel. This gets distributed. So I get 3x plus xy equals 2. We're solving for y. So I'm going to subtract the 3x. And I'm going to divide by the x. This is f inverse. This is f. Okay. Alright. Now, if your inverse checks, then I want you to go ahead and do the composition. Now this is going to use something that you've only seen once in the last video, I think it was, where we were simplifying fractions in a fraction. If you want to watch the first one and then try it yourself on the second one, you could. But I'm going to show you what that's going to look like. I'm going to do f of f inverse. It's not terrible, but it's going to look terrible for just a moment. This means put inverse into f. This whole thing in here. Okay, here we go. 2 minus 3x over x into here. So what is our denominator that's causing all the problem? X. So I'm going to multiply everybody by x. Everybody gets one. In algebra, it's very fair. We're going to take 2x. This is 3x. And this cancels. And I have 2 minus 3x. That's playing wonderfully for how we want to happen here. I want to simplify the denominator. You see something I could do? We're going to put those x's together. So I've got 2x on top, and 3x minus 3x is 0, so I just have 2 left. Uh-oh, you see that? Cancel the 2's. Yay! Alright, you feeling braver now? Let's go do the other one. Hit pause and do your other composition. Okay, for the second one, I have this. I'm going to take the f function into the inverse. This whole thing goes in here and here. Alright, if that's not what you did, hit pause and go back and fix it. Alright, I got a little more room here. 2 minus 3 times 2 over 3 plus x over 2 over 3 plus x. Okay, in the numerator, I can't really do anything until I get rid of these denominators. So I'm going to multiply by x plus 3 plus x. Will that make you a little happier if I keep it in order? I'm going to multiply this by 3 plus x. I'm going to multiply this by 3 plus x. And I want to stop here and just say 3 is already being multiplied by this. And so when I multiply by 3 plus x, it's times this whole term. Remember, terms were things added and subtracted. So I'm multiplying 3 plus x by each term. Okay, so this becomes 6 plus 2x, because I distributed my 2. This becomes 3 times, gone, 2. This becomes, gone, 2. This is plan coming together. I'm going to simplify this numerator. The 3 times 2 goes together. Ooh, do you see what's happening? 6's cancel, 2's cancel, x. Therefore, QED. Or, therefore, f is 1 to 1. Nice! And you got to learn Latin at the same time. You're welcome. Alright, go do your homework. Good luck. If it says to check algebraically, you need to show your steps.